Today we're going to present about practical project line detecting robots video presentation. Here is my group members. My first group members Ashab Ahmed is telling about the circuit design, and my second group member Samin Al Wasi also telling about the firmware, and my third group member Hafsa also telling about the Android app development, and me Abhijit Kumar Ghosh also telling about how to upload the file and check the project also.
An infrared sensor is an electronic device that emits in order to sense some aspects of the surroundings. These types of radiation are invisible to our eyes, which can be detected by an infrared sensor. The emitter is simply an IR LED and the detector is simply an IR photodiode, which is sensitive to IR light of the same wavelength as that emitted by the IR LED. When IR light falls on the photodiode, the resistance and the output voltages will change in proportion to the magnitude of the IR light received.
Hello everybody, myself Mohammed Samin Al-Wasi. So now we are going to take a look at our PID algorithm. So to implement the PID algorithm, we have created two new functions called PID control and move LFR. The PID control actually takes in the current position, which is calculated by the QRS sensor with the read line black method, and the move LFR method or function actually moves the robot, taking in the parameter speed change, so it adjusts the speed. So at first we are going to take declared three variables kp, ki and kd. So these three variables will be initialized, and kp can be initialized into one value and then it can be adjusted according to our robot's performance. Then we are going to when we are going to call the sensor data method in the loop, in our main loop, then we are going to call the PID control method and give in position as the parameter into it. The PID control method or function takes in the current position and then it calculates the error. So according to the when it calculates the error gets positive or negative. So whether the error gets positive or negative, it also calculates the P, I and D and also the integral error. So all the error is combined with the previous errors, and the differential error, which is the actually the position error, the current position error minus the last error. Then the adjusted speed will be kp into position error, ki into integral error, and kd into d. So in our case, k and kd is currently 0. We have to adjust those if we need. If it's not needed, then it's fine. So the move LFR method will take in the adjust speed, which is calculated. Then it will write in two motors thus adjusted speed. So one motor will be increased and other motor will be decreased. So if the speed change is negative, it will also reverse. So the positive one will then decrease and the negative one will that then increase. So also the constraint method makes sure the speed of the motor does not go below 0 or over the base speed, which is 100. So we have to set a slower speed to get a better performance from our robot. So that was it about the PID algorithm. So then we have to run the PID algorithm, then we have to control our LFR according to it. So that was all. Thank you everyone.
Assalamu alaikum everyone. Here I will talk about the Android app which we have created using MIT App Inventor to control our robot through commands. First we created a project called Mass Solver. Then from the designer section we designed its layout. We are using a Bluetooth and 4 direction command button for the robot, and we are also using the Bluetooth client, clock and text to speech. Those will help to integrate the command between robot and app. Now moving to the block section where we design the programs of this app. Here when we click on the Bluetooth, it will show all the available Bluetooth devices along with the name and addresses. By clicking any of the device, we can it will call a Bluetooth connection message for that particular device. Now if it is connected properly, then it will show a green color message that is connected, but if it is not, then it will show a red color message that is not connected. And these are the four direction command for the robot. We are using 4 individual string value to make our Arduino understand about the commands. And when you click on any of the command button, then it will receive that corresponding string value and make the robot move accordingly. Then in the meantime, the app will display the message using message display and also speak that message using text to speech. Suppose we have clicked on the right command, then the app will pass a value string value 1 to the Arduino, and by receiving this, Arduino will understand that the user has selected right command and move the robot to the right side, and our app will show the message right and also speak that message immediately. Similar things goes for left, up and down, and we are using 0 for left, 1 for right, 2 for up and 3 for down. By clicking down command, we can stop the robot, otherwise it will keep moving. Now by this our app making process is done, and from the build section we can download the .apk file and copy and install it to our phone to control our robot. That's all from my side. Thank you.
Pressing the uploading sign, the code is compiling now. The code is compiling and the code is uploading here, and the code is uploading successfully. Before upload the code, I check the port is connected with COM7 and the board is connected with Arduino Nano. To change the mode from Bluetooth to calibration mode, firstly we have to turn on the switch. Then the light is not blinking that time. Then we have to move the circuit from this way. This time the air sensor gives some random value in the Arduino Nano serial monitor. When the black line is in air sensor's first position, the value is bigger than the rest of the values of air sensor. This will happen with all the position of air sensor. This time the robot is in calibration mode. The air sensor take time to sense the line very carefully. Then I put the robot on the line. Then air sensor detect the line very carefully and going on. And this is from our presentation. Thank you so much.